Okay, big confession. I don't believe in magic. I do believe in math. And if you remember, math is better than magic. It's way more stronger, way more powerful because it's real. So let's break this down. I'm going to show you the real math behind this and why it actually works. And it's just an algebra problem. So you're starting off with any number. Let's say you started off with 8. And if you did the steps sequentially, you did end up with 3 at the end. So sometimes kids make a little mistake with just the arithmetic part. So you started with a number and you added 5, whatever the number is. And then you doubled that number. So whatever that sum was, you doubled. You subtracted 4. Then you divided by 2. And your last step was to take whatever your original number was and subtract again. And you end up somehow with 3. And it didn't matter what you picked. This was always true. So let's figure out why this actually happens. We know that has to do something with our expression. So I'm going to just remind you of the order of operations. We have them here. This is just convention to remind us of which operations do before another one. And to be fair, there are times I know that we can do things in a different step, like distributing. We're going to get to that in a second. But let's say I want to actually write all this out as an equation because we know our answer is going to be equal to 3. So we're going to start with a number. And we're supposed to add 5. So a number plus 5, doesn't matter what it is. And then we're going to multiply by 2. So here's first problem. We have to add first. So what I'm going to do is I'm going to put a parentheses around the number plus 5. And I'm going to put the times 2 in front. Okay, that's telling me a number plus 5, then times 2. Now I'm going to subtract 4. And this is again where it gets a little tricky because I have now divide by 2. I could put another parentheses all around here. That's one way. But I'm going to represent it in a fractional form because that's what we're teaching kids to do right now. So I'm going to write it in a fractional form, divided by 2. And we're saying next, we're going to, after we divide by 2, all of this, we're going to subtract our original number n. And this will equal 3. So this is what we have so far, okay? So our steps are still there. We're still going to start off with a number times 5. Then we're going to double it. After that, we're going to subtract 4. Then after we do all that, we're going to divide it by 2 and subtract our original number. So it looks, again, very complicated. We're going to simplify it out to show the math behind that. So the very first thing I'm going to do is I'm going to actually choose to distribute. I want to make this simple because this looks like a big old mess. This is a lot. And I'm going to show you how to simplify it out. Just by looking here, well, the first thing that we can do is we can distribute. I can do 2 times both of these numbers. So when I do that, I want to give myself a little space. 2 times the number plus 10. Okay, because no matter what, I'm doubling whatever that number is, so 2 times that number, and whatever the 5 was added to it is also being doubled, so that is 10. Minus 4. All this is over 2. Minus n equals 3. Okay, so it looks a little better. Now, looking at it, is there anything else we can simplify? We're going to use another term. We're going to actually combine like terms. So looking at this, there is a place where I can combine. I can combine these guys together. So 2n plus 10 minus 4. I can do that, 10 minus 4. And I'm going to get 6. So 2n plus 6. Look how much it's getting smaller and smaller. Divided by 2 minus a number equals 3. It's looking better. Now, here's the other thing. 2n plus 6 divided by 2. I'm going to divide both of those terms by 2. So I'm actually going to rewrite that. And I'm going to separate this because I want to divide both of these by 2. And I can do that because there's a plus sign in the middle, so I can divide both terms by 2. So if I had 2 n's, so 2 divided by 2 is just 1. So I'm going to be left with 1n. And 6 divided by 2 is just 3. So now this is what I have. Look at how much smaller and smaller. Actually, I'm going to move this down a little bit more, just for fun. And look how tiny we got it now. And you may be looking and you can see it. We have another like term here that we can add together. We can put these two together. And this is why, Math Marbles, this is why it looks like a trick. A number minus a number plus 3 equals 3. No matter what number we put in here, because we're subtracting it again at the end, this is always going to be 0. Doesn't matter. That's why when it's 8, I'm somewhere later in the problem, at the end of the problem, I'm going to subtract that 8. And that's going to make this turn into 0, into nothing. It goes away. And that's why, Math Marbles, this feels magical. Like, how did that happen? It's really just algebra. It's just simplifying out this problem. And because of the order of operations, because of the way we've written the expressions down, we know how to do that. The trick, because it looks like a trick because we're going down a list and we're just doing it in those specific steps. But when you actually do the math, a number times a number, these two will always cancel themselves out. And we'll always just be left with 3 is equal to 3. So you see, Math Marbles, it's not magic. It's just math. And that's it for today. I will see you in the next lesson, but I will tell you sometimes magic is pretty much fun. So feel free to try this on others, and the real fun will be when you can explain the mathematics behind it. I'll see you in the next lesson. Be well.